Welcome to my 16th tutoring session in A-level chemistry. In this video, you will learn about modern periodic table of the elements. Because of the vastness of the topic, I'll be presenting in a three-part series. Now the current part 2 video is a continuation of the previous part 1 video about the periodic table. Periodic table is a versatile tool to organize and understand the properties of elements. In the periodic table, you'll find a total of 118 elements, of which 94 are naturally occurring on Earth, while the rest 24 are of synthetic origin. That is, these 24 elements are synthesized in the laboratory using nuclear reactions. Now, in the periodic table, elements are organized in 18 columns called groups and 7 rows called periods. Period 1 elements in row 1 have just one electron shell. Period 2 elements in row 2 have 2 electron shells. Period 3 elements in row 3 have 3 electron shells. Period 4 elements in row 4 have 4 electron shells. Period 5 elements in row 5 have 5 electron shells. Period 6 elements in row 6 have 6 electron shells, and period 7 elements in row 7 have 7 electron shells. Now going down the group, you see the number of shells increase. So as the number of shells increase going down the group, the size of the atom increases. Now in the periodic table, as you move across a period from left to right side, you find the groups numbered. So as per the IUPAC system of numbering, the groups are numbered from 1 to 18. So each group is assigned a number. But we prefer the traditional numbering system using Roman numerals. So I'm numbering only the important 8 groups, and the elements from group 3 to 12 are the transition elements with variable oxidation states, and this topic will be dealt in detail in my next video. So watch out for that video. Now group 1 elements have 1 valence electron in the outermost shell. Group 2 elements have 2 valence electrons. Group 3 elements have 3 valence electrons. Group 4 elements have 4 valence electrons. Group 5 elements have 5 valence electrons. Group 6 have 6 valence electrons. Group 7 elements have a total of 7 valence electrons in their outermost shell. And group 8 elements have a total of 8 valence electrons. Now the group 8 elements are chemically inert due to their stable electronic configuration, with their outermost shell completely filled with a total of 8 electrons, and therefore they are chemically inert or unreactive in nature. So group number is equal to the number of valence electrons. That is, group 1 elements will be having 1 valence electron, group 2 elements 2 valence electrons, group 3 elements will be having 3 valence electrons, so on and so forth. And about their oxidation numbers, group 1 elements has an oxidation number of +1, group 2 elements +2, group 3 elements +3, group 5 elements -3, group 6 elements -2, group 7 elements -1, and group 8 elements with an oxidation number of 0 because of their chemically inert nature. and stable electronic configuration. Now in the periodic table, each element is assigned a box, and within the box, you'll find the details about the element. Like some of the common details that you'll come across will be element's symbol, name, atomic number, and relative atomic mass. Now, each element in the periodic table is assigned a box, and within the box, you'll find some of the basic information about the element. Now, I have considered chlorine as a representative example to explain the basic information about the element in the periodic table. So, name of the element, symbol of the element is Cl. First letter is uppercase followed by the lowercase letter. Now the symbol can be 1 or 2 letter abbreviations for the common name. Now some of the examples with 1 letter capitalized abbreviation. Now C is the symbol with 1 letter capitalized abbreviation for the common name carbon. N is the symbol with a 1 letter capitalized abbreviation for nitrogen. O is the symbol with a 1 letter capitalized abbreviation for oxygen. And some of the examples for elements with 2 letter abbreviation. Now in case of elements with 2 letter abbreviation, the first letter will be capitalized followed by the second letter in the lower case. So AS is the symbol with a 2 letter abbreviation for the common name arsenic. BR is the symbol with a 2 letter abbreviation for bromine. You find the first letter B is capitalized followed by the second letter that is in the lower case. Now Cl is the symbol for chlorine with a 2 letter abbreviation for the name. Now there are some elements in the periodic table and their names are unrelated to the symbol. Why is that? Because these elements have been derived from Latin, because they were discovered in ancient times. For example, sodium symbol is Na because its Latin name is natrium. Potassium element symbol is K because its Latin name is kalium. And for gold, symbol is Au, derived from Latin name aurum. And element lead, symbol is Pb, derived from the Latin name plumbum. So this is about the symbol of the element. Now coming to the most important information about the element, that is atomic number. Now atomic number, it gives identity to the element. What is atomic number? Atomic number is the total number of protons, positively charged protons present in the nucleus of the given atom. So atomic number of chlorine is 17 because the total number of protons, positively charged protons present in the nucleus of chlorine atom is 17. So atomic number of chlorine is 17 and therefore it is the 17th element in the periodic table. Other examples, hydrogen atomic number is 1 with 1 proton in its nucleus. Atomic number of carbon is 6 with 6 protons in its nucleus. Atomic number of nitrogen is 7 with 7 protons in its nucleus. Atomic number of oxygen is 8 with 8 protons in its nucleus. So why hydrogen is the first element in the periodic table? Because its atomic number is 1. Why carbon is the 6th element in the periodic table? Because its atomic number is 6. Why nitrogen is the 7th element in the periodic table? Because its atomic number is 7. And why oxygen is the 8th element in the periodic table? Because its atomic number is 8. And what about chlorine? Chlorine is the 17th element in the periodic table because its atomic number is 17. It has a total of 17 positively charged protons in its nucleus. So atomic number, it gives a unique chemical identity to the element. and say one of the most important properties in the periodic table. And in the periodic table, you can find the elements are arranged in the order of increasing atomic number as you move from left to right in the periodic table. Now, why is the relative atomic weight of the element is in decimals and not in integers or whole numbers? The reason is some of the elements exist in their isotopic forms. Now, the relative atomic mass of chlorine will be the weighted average of its naturally occurring isotopes, that is chlorine 35 and chlorine 37. So when you take a weighted average of these two isotopes of chlorine, that is 35 and 37, you'll end up with the value of 35.45 in decimals. So relative atomic mass or relative atomic weight, what is mentioned in the periodic table in decimals, is a average atomic mass of the naturally occurring isotopes. It's the weighted average mass of its naturally occurring isotopes. In case of chlorine, you have to take the weighted average mass of isotope 35 and 37. You get the value of 35.45. And that is about the relative atomic weight of the given element, given in decimals, not in integers or whole numbers. Now, these are some of the basic information you will find in any given periodic table, but some periodic tables you will come across an exhaustive list of properties. Like in case of chlorine, you may find in some periodic tables exhaustive list like its electronegativity. On Pauling scale, electronegativity of chlorine is 3.2. You'll also find some additional details like electron affinity, melting point, boiling point, density, ionization energy, including its units. So all these properties will be mentioned in the periodic table, including its units and even the group to which it belongs. So chlorine, it belongs to group 7, that is, it belongs to halogens. Group 7 are halogens like fluorine, chlorine, bromine, and iodine. And even the oxidation state of chlorine is -1. And electronic configuration. So this is one of the important properties that you'll find in the details that you'll find in the periodic table. And always the electronic configuration will be a condensed electronic configuration, not the lengthy one. You'll not find periodic tables with the complete electronic configuration. You'll find only the condensed electronic configuration. So don't forget to subscribe my channel, share and like my videos. Thank you so much for watching my video. I hope you enjoyed it. And I'll meet you in the next concluding part of this series on periodic table.